Welcome. In today's lecture, we are going to look at number basis. Okay, it is a concept that helps us understand numbers better. We understand the numbers better. Okay, so we're going to look at their concepts and conversions. Okay, so these concepts are used in computer programming and other numbers. Okay, so make sure you know this before you go on. Okay, and this question is increasingly being asked in examinations. Okay, so make sure you master it. So in this lesson, I'm going to make sure that by the end of it, you're going to be able to understand what is a number base, okay, and understand the derivation, how many numbers do we use in this current, and how many number bases do we have. Okay, we have many number bases. Then we have identify a place value of a digit. Okay. Then you can see that convert a number from base 10. Okay, we usually use base 10, which is decimal, and to other bases we have example of binary, base 5, base 8, and other bases we are going to use. Okay. Then the next thing is you're going to convert a number to base 10. Even a number in base, this one, you're going to change from other bases to base 10. Okay, so our limit today is going to be up to base 10. Okay, we have another base which is base 16. We are not going to use it here. So let's take a look at what we are going to do today to make sure we master these number bases. So make sure you subscribe so that you don't miss on and other concepts which are very important, which are going to come. First, let's understand the definition. Okay, so the definition is a number base, it is also called a radix, is a number of different digits, or symbols used to represent numbers. Okay, so in the current world, when you use the numbers, we use numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this 10 is not going to be included here because we see that we are going to repeat 1 and 0. Okay, so these are how many numbers do we have here? We have 10. Okay, we have 10 symbols, 0 and 1, 2, 3, 4. These are the number of symbols. Okay, so we can say that this is these numbers are in base 10 because we have 10 different symbols. Okay, so if we use these symbols to represent numbers, we only use 0 and 1. If we were to use only these two, okay, this means that our number is going to be in base 2. Okay, so if we use 3, 1, 0, 1, 2, our number is going to be base 3. Okay, so this is what it is, the number of different digits or symbols. Okay, if we go to base 16, we're going to be using A, F, A, B, C, D, F, including this. Okay, so they become 16. Okay, so it's the number of different digits or symbols. Okay, so we have the common bases which are binary. Okay, so when you see it is binary, it is in base 2. Okay, so this is the base 2. Okay, then we have other numbers in base 5 and base 8. Okay, these ones are very common. Okay, so we're going to take a look at these bases. Okay, so the first thing, the definition is how many digits are we going to represent a number with. In base 2, we just represent with 0 and 1. In base 3, we just represent with 0, 1, 2. And in base 10, which we use every day, we represent it with 10 different symbols. Okay, so this is our base numbers. Okay, now let's talk about place value in any base. Okay, so let's say you are given number 493. Okay, so if you want to take the place value of 9, okay, the place value of 9 here is 10, is 10, right? Is 10. Okay, so do you know how do we get this 10? Okay, here we can see that the place value of this 4 is 100. Okay, so do you know how do we get this? Okay, so this number is in base 10. Okay, the numbers we use every day are in base 10. Okay, so if you want to find the place value, this 10, okay, of it, this one, okay, we just have to count here from 0, 1, 2. Okay, so the place value of 3 is going to be 10 to the power 0, which is 10 to the power 0. 10 to the power 0 is 1. This is the meaning of a unit. Okay, then here you can see that if you say 10 to the power 1, you're going to get 10. Okay, this is this 10 here. Okay, so this is how we say the numbers we use every day are in base 10. Okay, so if we count from here, from my right, 0, 1, 2, we will get this 10. This becomes a unit, and this one becomes this. Okay, so this is what we call a place value. These numbers are what we call a place value. And if you say take this 4 again, you can see that it becomes 10 to the power 2, which is equals to 100, which is this one. Okay, so this is what we call place value. Okay, so let's say in other bases, if you want to find a place value of other bases, let's say you have a number 2, 1, 0, 1, base 3. Okay, so this is a number in base 3. Note that these numbers on this base can never be greater than this number, or equal to, can never be greater or equal to this number. Okay, so make sure that these numbers, they can never be greater than or equal to this number. Okay, let's say you have this one. You want to find the place value of this 0. What you do is you just count 0, 1, 2, 3. Okay, what you're going to take is you're going to take 3 to the power this number. Okay, so 3 to the power 1 is going to be 3. Okay, so meaning that the place value of 0, place value of 0 is 3. Okay, then here you can see, now let's say you want to find the place value of this 2. You can just say 3, this 3 to the power 3, you get 27. Okay, so the place value of this 2 is 27. Okay, so this is what we call the place value of any base. Okay, so here you can see that our unit, 10, 100, 1000, and so on and so on, they are our place values is this side when you are using base 10. Okay, here we're using base 3. You can see that our place value are going to be 1, 3, 9, 27, like that. Okay, these are our place value. Okay, so if I tell you find the place value, you are going to find it easily. Try to find the place value of this number 4023. Try to find the place value of 0. This number is in base 5. Okay, and check if you are able to make sure that the place value of this number is 25. Okay, so this is a, make sure you are able to find out that the place value of 0 is 25. Okay, let's go on and see how do we convert numbers from base 10 to base 3 to base 2 to base 5 to base 8. How do we do that? Our first concept is going to be converting from other bases. Okay, given other bases, base 10. Okay, so how do you do that? The first, these are the steps. The first step is to write down the number. Okay, then label the powers of the base from right to left. Okay, you know, when I do it, I've already done it. You just have to remember that. Then multiply each digit by its place value. Okay, so we're going to find its place value. Okay, then add the results. Okay, so the first thing is, let me do example. Let's say you're given a number 1101. Okay, base 2. Okay, this is the number in base 2. Okay, the first thing you are going to write down the number like this. We have successfully written the number. Okay, then label the powers of the base. Okay, so this is our base. The powers of the base are going to be here 0, 1, 2, 3. These are going to be our powers of the base. Okay, so what we're going to do, we're going to multiply each digit by its place value. Let's start here by 1. This means that we are going to say 1 multiplied by its place value. How do we write a place value? We just take this 2, then take this power 3. Okay, then we say plus, then 1 times 2 to the power this 2 becomes 2. Okay, then here we say this one plus 0 times 2 to the power the 2, this is 2, and to the power 1. Okay, times here 1 times 2 to the power 0. Okay, so we can see that this one was our base. Okay, this one was our base, this 2, and this one was our power, which we do this, and these ones are our digits, a 1, 1, and so on and so on. Okay, now let's take a look at this number and this number. This number is our place value of this number. This number is our place value of this number. Okay, this number is the place value of this number. Okay, so now our duty is just to add. Okay, so here we can say 2 times 3 is equals to 8 times 1, which is going to be 8. Then plus here 2 times 2 is 4 times 1, which is going to be 4. Then plus 2 times 1 is going to be 2. 2 times 0 is going to be 0. Times, and then here 2 to the power 0 is going to be 1. 1 times 1 is going to be 1. Okay, so our number in base 10 is going to be 8 plus 4, which is 12, plus 0, 12 plus 1, which is equal to 13. Okay, so this is going to be 13 in base 10. Okay, so if we change this number 1, 1, 0, 1, base 2 to base 10, we're going to get this. Okay, so if your number is in base 10, you can simply write it without this base. You can write it's 13. Okay, so this is how we convert it. Okay, so given any number, what you're going to do is you're just going to multiply this. You get first, just have to label the powers like this 0, 1, 2, 3. Then you just have to multiply each digit with its place value. You multiply this, its place value, this and its place value, like I did here. Okay, so try an example. Let's say I given 3, 4, 1, base 5. Try it and get an answer and comment in the comments what did you get on this. Okay, you can say our answer for A. What did you get? Okay, so let's go on to our next, where we convert a number from base 10 to other bases. Let's go on our concept, converting from base 10, given a number in base 10 to other bases. Okay, so these are the steps. Divide a number by the new base. Okay, you want to change it from base 10 to other base, so you just have to divide the number by the new base, the new given base. Then record the remainder. You will be recording the remainder and continue dividing until the quotient is 0. Then we have to write the remainder in reverse. Okay, so let me give you a simple process of doing it. Let's say you are given a number. In this case, let's say it's 34. Okay, 34 is in base 10. Okay, you are being asked to change it to base. Let's say you are being changed to base 5. Okay, this is easy. Okay, so the first thing you have to do, you just have to write a table like this, so that your recordings will be easy. Okay, you write a table like this. Then you write R here for remainder. Then you write this 34 here at the middle. Then you write this 5. Okay, this is the new base. Okay, the base 10, the base 10 you already know. This is what you do. You want to change from base 10 to base 5. Okay, so now what you're going to do is we're going to divide this into this and write the remainder. Okay, so here we can see that 5 into 34 is 5 into 34 is 6, remainder 4. Okay, then now we say 5 into 6 is 1, remainder 1. Then you say 5 into 1 is 0, remainder 1. Okay, so now we just have to write our remainder in this way. Okay, so this means that our answer is going to be 1, this 1, 1, 4, base 5. Okay, so this is going to be 34 base 10 is equals to 114 base 5. Okay, so as easy as that. Okay, so given any number, in this case, we just have to put that number here and put the new base here. Given any number in base 10, you just have to put the number here and the new base you want to change to here. Then divide until you get, then you will be recording remainders here. Then you count the remainders in reverse order. Okay, so I want you to try how do we convert 17 base 10 to base 2. Okay, so I want you to do this and comment in the comments. You can say this is your question B. Comment what did you get. We have our examples here. We are going to take a look on these examples. Okay, so the first example says that convert 2102 base 3 to base 10. Okay, so we're going to convert this number, which is in base 3, to base 10. Then the other thing is we're going to convert 54 to base 4. Okay, so we're going to do that here. Let's start with our number 1. Okay, so I told you that the first thing we have to write a number like this, 0, 2, 3. Then the second thing, we just have to write the powers of the number. Okay, so the powers, we are going to start from here, 0, 1, 2, 3. Okay, so after doing that, you just have to take a number and multiply it by its place value. The place value, you get it by saying 3, this base, to the power this position which it is. Okay, please pay attention here. You say 3 to the power this number you get here. Then you times 2. Okay, so in this first case, you are going to say 2 times, right? 2 times, then you say 3 to the power this 3 to the power this 3. Okay, then plus our next number, which is 1 times, then you say 3 to the power this 2. Okay, so it becomes 3 to the power 2. Then plus, here we have 0, so you're going to say 0 times 3 to the power this 1. Okay, then plus this is 0, and this is 2 times 3 to the power 0. Okay, so we're going to solve this and see what we get is our answer. Okay, so the first thing is you are going to multiply here. 3 to the power 3 is 27 times 2. It gives us 54. Plus, then here 3 to the power 2 is 9 times 1, which is equals to 9. Then plus here 3 to the power 1 is 3 times 0, which is going to give us 0. Plus here we're going to say 3 to the power 0 is 1 times 2, which is going to give us 2. Okay, so we're going to add this. Okay, 54 plus 9 is going to give us 63. 63 plus 2, we're going to get 65. Okay, so this means that our answer is 65 base 10. Okay, so this one we can say write base 10, or we cannot write. If you see any number which is not written, it means that it's in base 10. Okay, you can just write 65 base 10, or you can write 65. Okay, it's equal. Okay, so this was the first question. Let's go and take a look at the second question. Okay. The second question says that convert 54 to base 4. Okay, so I told you that if you want to convert, if it's written like this, 54, it doesn't have a base here, it means that it is base 10. So what we're going to do is we're going to draw a table like this. Then you write R here, then you write 54 here. Okay, so we're going to say for our 4 here, this is our new base. Okay, this is our old base, which is base 10. Okay, so what we're going to do is we're going to say 54, 4 into 54. Okay, so in this case, we're going to get 1 here, 1 here, then you put 1 here. We get 4 into 14, we're going to get 3, remainder 2. Okay, then we're going to say 4 into 13, we're going to get 3, remainder 1. Then we're going to say 4 into 3, we're going to get 0. Okay, 4 into 3 is 0 here, then remainder 3. Okay, so we just have to read this. Okay, you stop dividing when this number becomes 0. Okay, so this means that we are going to get our answer is 54 is equals to 3, 1, 2 base 4. Okay, so this is how we do it. You just have to do our division and until we get this. Okay, so this is our question 2, and this one's our question 1. Okay, so this becomes our answer. So make sure you follow this. Okay, so we are going to be uploading the next question where we add, multiply, or divide numbers in bases. Okay, so we're going to subtract again the numbers in these bases. Okay, so make sure you subscribe so that you don't miss that video, and make sure you watch it if it is there, and make sure you grab this concept and practice. Okay, make sure you comment in the section the answers you got on the 2 examples, and make sure you comment your next topic you want me to do. Okay, thank you.